This arc here is 268. The rest of it that's showing is 360 minus 268. So you take 360, subtract 268 from it, and you get 92. So if the arc is 92, the angle is half of that. So you divide that by 2, and you get 46. So that's what 41 should be. The arc is twice the size of an inscribed angle. If the angle touches the edge of the circle like this one does, then you just double it to get the arc and half the arc to get the angle. So now we have to move the 17 squared and the 15 squared to the left. So it's 28 squared minus 17 squared minus 15 squared. And that gives me 270 equals negative. And negative 2 times 17 times 15 is negative 510 cosine of C. Now I'm ready to leave the cosine of C alone. So I take the 270 and divide it by negative 510. Everybody understand that? And I get an ugly decimal. Cosines and sine are always going to be ugly decimal when you're looking for the angle. But when we're looking for an angle, what button do I push?
Second.
So you hit second sign of second answer of that ugly decimal, and you should get, do you get a negative on this one?
No.
So second cosine of that is 121.97 degrees, and that's your big C. We would keep going. We would do it again for B or A, and then subtract the 2 from 180. But on the test, I'm only going to ask you for one thing, so you just would stop. You have to use the law of cosine, and since we need to find big A, we need to find the one with the A in it. A squared equals B squared plus C squared minus 2BC cosine of big A. And this is very simple because, well, not really. You're still finding big A. So A squared would be 16 squared equals, so the first thing you have to do is find little c, which is 36.37 as per one of our students. Let's see if it's right. So little c is going to be c squared equals A squared plus B squared minus 2AB cosine of big C, right? So c squared, we don't know. Let's pretend we don't know it. A squared is 16 squared plus 30 squared minus 2 times 16 times 30 times cosine of 100. And we're going to put that all in the calculator in one row. Okay, so when you do in this case, you have to find little c first using the law of cosine, and then you find little a, or big A, by using the law of cosine. So it gives you that big A is 25.67 degrees. They want us to use the law of sine. So we say sine of C over little c equals sine of big B over little b. Since we don't have anything with A's in it, don't worry about the A.
Wait, don't you get 18?
So we're going to plug in, yes. We plug in what we have. So we have sine of 89 over 33 equals sine of B, big B, over 18. We're going to cross multiply. So we have 18 sine of 89, make sure you close that parentheses, equals 33 sine of big B. And then we're going to divide by 33. And you're going to get an ugly little decimal. You should get 0.5454 equals sine of B. And then you just hit second sign of second answer, and you get 33.05. So big B equals 33.05 degrees. I am an artist, so you guys, just read it and weep. Here's my lighthouse. From the top of a 108-foot lighthouse, so we know that this is 108, right?
Yeah.
An angle of depression of 27. That's 27 there. Find the horizontal distance from the boat to the base of the lighthouse. They want this guy right here. Well, whenever they give you the angle of depression, they're also giving you the angle of elevation, which is the guy on the floor, because those two lines are parallel, so they're alternate interior. So you've got a right triangle That is a 27 degrees, x, and 108. Well, 108 is the opposite, and x is the adjacent. So we got tangent of 27 equals 108 over x. We cross multiply. We get x tan of 27 equals 108. We divide by tan of 27. Notice I haven't picked up my calculator yet. Don't do it until the x is alone, and then I put it in the calculator. So that boat is 211 feet or meters or whatever the unit of measure is on here. From the base, and if they say to the nearest, it would be 212. It would be whatever they ask you. Big B for number 58 would be 7 times 11. It's the area of that rectangle that's on the ground. So it's 77. Number 51 is the lateral area of a prism. So what is the formula for lateral area of a prism?
L equals P, big P, H.
Big P and H, okay? But the H is the height of the box. It's a weird shaped box that they shipped you something in. And the P is the perimeter of the base. In this case, the base is a trapezoid because there's 2 trapezoids and 4 rectangles. You see that?
Yeah.
So the perimeter of the base is going to be 5 plus 5 plus 5 plus 9. So 15 and 9 is 24. And the height of that whole thing is 12.
Wait, I'm confused.
Because the box is 12 feet high. When you lay the trapezoid on the ground, it's 12 feet high. So what's that, 288? In this case, on number 60, you also have a trapezoid that is the base. So to find the area of a trapezoid, big B is going to be 1/2 base 1 plus base 2 times H. So that's 1/2, and the base 1 is 7 plus 4 times the height of the trapezoid, which means if you jumped on the roof of the trapezoid and jumped down, you would be falling 3.7 feet. And so you multiply those together to get big B, 0.5 times 11 times 3.7, and you get 20.35. So big B is 20.35. Now you have the height of the whole prism is if you put the trapezoid on the ground, how high is it? And it's 6 feet high? So multiply that by 6, and you'll get 122.1.